Hello everyone, this is Mr. Appel, and today we're going to talk about similar polygons. Similar polygons. So, oops, here we go. So, by definition, polygons are similar if they have congruent angles. So if all the corresponding angles, all the angles that match up, corresponding angles are congruent, and the corresponding sides are proportional. So when we had congruent polygons, the angles and sides had to be congruent. But here, for similar figures, they don't have to be congruent. The side lengths just have to be proportional, in other words, in the same ratio. And we'll explore that a little bit here and in class. The ratio of the corresponding sides is called the scale factor. That's some vocab you may be familiar with. And it can be written in that colon form, or you could write it, of course, as a fraction, or in other ways, sometimes even in decimal form. And the symbol for similar is that little squiggle, kind of what's on top of a congruent sign without the equal sign, because they're not equal, they're just kind of equal. Okay, so just to see what that looks like, if we have these two polygons, two pentagons in this case, if they're similar, we name that similarity. The order is important, was what I'm trying to say. In the same way that when we name congruent polygons, we had to name them using the letters in the same order, right? In the order so that the corresponding parts match up. So A goes with A prime, B goes with B prime, C goes with C prime, and so on. So when you write this congruence or this similarity statement, just like with a congruent statement, the order A, B, C, D, E, each of those vertices goes with A prime, B prime, C prime, D prime, E prime. So when you have a statement like this one, you know that angle A is congruent to A prime, angle B congruent to B prime, all the corresponding angles are congruent. That's what this says here. But now, with congruence, we would have said that AB was congruent to A prime, B prime. We would have said that this and this were congruent. But now we're talking about similarity, so we say they are proportional. In other words, they're in the same ratio. So for example, just to keep it simple, if AB was twice as big as A prime, B prime, then all the others would be twice as big as well. Not that they're all the same, but that they're in the same ratio. Okay. So let's look at an example. So here we've got, again, two similar pentagons. We've got a scale factor here. So the scale factor, again, is the ratio of corresponding sides. Well, we've only got one pair of corresponding sides here, AB and A prime, B prime, but that's all we need. So the scale factor is simply the ratio from the first side to the second side. So 32 to 20, which we can reduce to 8/5. And what that means is all the other sides would have to be in that same ratio. So for example, if BC was 8, we would know that B prime C prime was 5, so that they would be in that same ratio of 8 to 5. If DC was 16, D prime C prime would be 10, because 16 to 10 is equal to 8/5. So they're in the same ratio. Okay, let's look at that in the context of a problem. So here you've got some lengths and some missing values. Notice we are given that these two trapezoids are similar. So I know all the angles, the corresponding angles are congruent. So angle A is congruent to angle H, and so on. But this problem is looking at side lengths. So the first question is to determine the scale factor. We need to determine the scale factor in order to write some proportions. So I need to find a pair of corresponding sides that I know the measures of in order to determine the scale factor. All right, so if I try to use AB, for example, I don't know what AB is, so I can't determine the scale factor. So that's not going to help me. But I notice that DC is 50 and GF is 30, and they correspond, right? DC, that's the last two letters, corresponds with FG, the last two letters, and I know both of those values. So I can determine that the scale factor is 50 to 30. So that's the scale factor. But of course, we always reduce the scale factor. We always reduce our ratios or simplify them. So our scale factor is 5/3. And you could write it as 5 to 3 if you want, but the fraction is just fine. Now that you know that the ratio of each side in this trapezoid to each side in this trapezoid is 5:3, you know they all have to be in that same ratio. That's the big idea with similarity. So for example, I know the ratio of 30 to x must be the same as 5:3. So I can write a proportion. 30 is to x as 5 is to 3. And then you can simply cross multiply and solve. So we cross multiply, we get 5x equals 90, divide, and we get x is 18. And you can do that same thing for, let's change colors here, for y. If I'm trying to solve for y, I see AB corresponds, that's the first two letters, is going to correspond with HE, the first two letters. So y corresponds with 12. So I can write another proportion that says that y is to 12 as 5 is to 3. Again, using that scale factor, 5:3, to write that. Cross multiply, 3y is 60, divide by 3, and y is 20. And that's our answer for y. And we can do the same thing with z. I know my page is starting to get a little messy here. I'm actually going to clear it just so I have some room, but you can rewind if you need to see all that. So 22, BC, the middle two letters, goes with EF, which is Z. So again, 22 is to Z as 5 is to 3. Cross multiply, we get 5Z equals 66. Divide by 5, and Z equals, what is that, 13.2? Oh my goodness, a decimal. That's okay, decimals are numbers too. So Z is 13.2. Okay, now the ratio of their perimeters, if we go back and calculate those perimeters, so Z was 13.2, X was, oh I forgot what X was now. What was X? X was, let's go back here quickly. So X was 18 and Y was 20. Sorry about that. So X was 18 and Y was 20. So if I look at the perimeters, the perimeter of ABCD is 50 plus 30 is 80, plus 20 is 100. So that's 122 is the perimeter, just adding up the sides. And then this one here is 30, 18 and 12 is another 30, that's 60, that's 73.2. So I'm curious if that ratio is consistent with the scale factor. And if you simplify 122, if you divide 122 by 73.2, you will get 1.6 repeating, which is the same as the scale factor, 5:3. Right, so the scale factor and the ratio of the perimeters is going to be the same. So in other words, the ratio of the sides is always the same. It's the same for each pair. And the ratio of the perimeters is also going to be the same. So the scale factor tells you all of that information. And that's all for today. Thanks.